I would like to welcome Professor Jiaguo Qi. Welcome back to GVSU. And Dr. Jiaguo Qi is director of the Center of Global Change and Earth Observations, and he's also professor of geography at the Department of Geography, Environment, and Spatial Sciences at Michigan State University.
Thank you so much, Lena. This is really a great opportunity for me to introduce some of the work that I have been involved to this group. As you and I said prior to this presentation, Michigan's, we have so many talents and so many people are dedicated to the climate change research and education. This is a great chance for us to get together. We need to do this more often than what we are doing now. So it's really a pleasure to be here and to present some of the work. And what I have done in terms of this presentation is to just introduce the concept and then have some discussion on the issues related to the water, energy, and food systems. I want to make it simple, and so that we can have general understanding, and then open the door for questions for in-depth discussion. I hope this presentation, provides some of the useful information for your research and for your classroom education. As I said, I will focus on climate change and its relevance to the water, energy, food securities, and the concept of the water, energy, food nexus. And then I use an example in the Southeast Asia to illustrate how the three are interconnected and the way we address those issues, and then how we can move forward in the future. Just from the concept perspective, on the left, you see that water, energy, food is interconnected through climate. Of course, we can, put land and put society in the middle circle as well. In any case, that's a concept of this water, energy, food nexus, which will be further explained to you. Starting with this, probably you have seen so many figures or pictures like this, but if you look at the what we call climate anomalies, you see that in the early 90s, 1905 to 1909, and then you see blue indicate less, climate anomalies, but as you move forward with states, and then going to the 20th centuries, 21st centuries, and then you get to much more anomalies on a global scale. So basically the message here is that climate is changing and anomalies are increasing, and then we need to develop meaningful, sustainable pathways to adapt or cope or mitigate the climate change. Particularly in the area of the food, water, and energy systems. Just give you some figures here. Water security, we have 1.2 billion people living in an area affected by physical water scarcity. That's just a fact. And this is the source from the FAO, okay? 1.6 billion people living in an area affected by economic water scarcity. So the difference between physical and the economic water scarcity. And more than 800 million people lack access to clean water. That's just a fact, okay? And food security, you see the numbers here. Okay, just give you, first number, about 900 million people go hungry each day. So those are the issues we're facing in terms of energy. people don't have sufficient electricity in their house, and they are just lacking access to the energy, and they need that energy in order to make their livelihood better. So we are in a society or in a world that a lot of people are suffering from the lack of water, food, and energy. How climate is related to food and others, food, water, and energy. This is just a chart on the price. Okay, it's in terms of food price. This is the wheat. Okay. If you look at any of the spikes in price, they are all corresponding to climate, a drought, flood, and how they are related to, this is on a global scale. And then if you look at how that climate change affects food, I use US example. This is the yield per acre. Okay, it's the bushels per acre, and from different years, since 1960, you can see where the dips in the yield corresponding to the climate events. Okay, so climate change, particularly, is having significant impact on food security here. The challenge we're facing is that we need water, we need food, we need energy. Where do we produce water or food and energy? Of course, we don't produce water per se, but how do we manage the water? Okay, we are asking the Earth to provide more resources each day, but we only have very limited resources on the Earth. And the example in the bottom chart is global arable land. And you can see that we have very limited global arable land that can produce food. Of course, we can explore ocean. Ocean is not unlimited in resources either. So how can we produce more food with the same amount of land? How can we generate more energy with the same resources that's available for us? How can we support increasing population and food production with the same water resources? So those are questions that we need to ask ourselves. What can we do to sustain the Earth and provide resources to ensure everybody has enough food, water, and energy? So those are kind of dilemma we have to face and we have to resolve. So in summary, this is the Earth in the middle, and by 2050, 1.9 billion people. It's just the fact. And those people, as we know, consumption patterns indicate that we're increasingly consuming more and more food, water, and other resources. So we need 60% more food than we have now, 80% of more energy than we have now, and 55% more water, fresh water we have now. So how can we ensure with these challenges, how can we ensure that we have a sustainable Earth? So there are numerous programs, and particularly the ones that the Future Earth, which is an organization that I have been involved for years. And one of the things that this organization is addressing is to ensure a global sustainability by developing different programs and connecting those programs to the society. And here is a chart or some of the events that highlights the development of the future Earth from early 80s and until now that we become, the organization becomes operational in 2013 as a future Earth organization. So large number of people are involved in this organization, and it provides a lot of guidance, scientific insights, and also research coordinations around the globe to address the very issue of sustainable society, sustainable Earth. So you can have a lot of information here. You can check online the publications. One particular aspect of the future Earth, dealing with this WaterEnergyFood Nexus, is they set out challenges, the grand challenges. Of course, at the time when we developed this future Earth vision, it was visioned for 2025. But you can see that we're only 5 years from now, to achieve that vision. But among the 8 challenges in the society, among the future Earth community, food, water, energy is a core. And it's related to the SDGs. I'm sure you all know the SDG, Sustainable Development Goals set by the United Nations. So this is a way that future Earth is to tackle the issues or address the issues, the SDG issues. So among many others, there is one organization or group that called WaterEnergyFood Nexus in the future Earth. They call it future Earth, WaterEnergyFood Nexus. And this group is one of what they call knowledge action networks. So this is a particular designed to address the water, energy, food security issues that faces the global community. It ensures to deliver water, energy, and food for all in a sustainable way. Okay, so this is just a list of the missions that the Nexus can attempts. And basically, the idea is to link research communities to the societal needs and then disseminate information and help the community to develop or design and implement sustainable pathways towards future, towards food, water, energy securities. I want to give you an example of the recent report, what has been done in the community. So this is a report. I don't want to have full report on this one, but you can check it out. So you can, this is a free download. The Future Earth is an organization. This report is our future on Earth. It highlights so many issues. One of them, say in Southeast Asia, identified is a food crisis, a water crisis, a biodiversity losses, the ecosystem collapse, extreme weather events, they call it climate change. So failure of climate change mitigation and adaptation. Those are the key issues facing in this area, but it's not just in South Asia. Rather, it is facing the global community. Why Nexus? I want to introduce the concept. Why, we talk about water, energy, food securities all the time. Why Nexus? Okay. Here is a typical example. In the framework of the Nexus, the notion is that water, energy, food is interconnected. We cannot solve a single problem without addressing problems in other areas. Okay. For example, if you look at this chart, water for food and land, or water for energy. So there is a competition for water. So if you change water in whatever way you do, you change the food production or energy production. That's the same thing when you change the energy or change the food systems. So in the past, research community has mostly focused on one or two areas without thinking of this nexus, the connections. So for example, the integrated watershed management approach, it is water-centric. But here, the notion is that we treat all three equally. So we are looking at them as a system with a climate in the middle that affects all aspects. So the framework was initially proposed in 2011 and rapidly adopted by the research community to develop solutions to address societal challenges. So this is one of the emerging areas of research, and Future Earth set up this community, the group to address those. So NSF has this, innovations in food, water, energy nexus, and it basically addresses the connections, interconnections, and interdependence of the systems. So the question is, how can we manage limited resources to deliver food and energy and water for all in a sustainable way? I think that's the topic that we are addressing, climate change and sustainability. So we really need to have innovations in our research, in our technologies, in our ways dealing or they communicate among or disseminate information with the society. So I want to use an example to illustrate how the group that at Michigan State University approaches this problem. So a hydropower dam example, hydropower, which by the default it means using water to generate energy. I don't know if you are familiar with some of the different data sets. This is the global georeference database of dams. You can see that entire Earth being dammed. What that implication is that a lot of natural flows being stopped and diverted for different purpose. So if I move to the next, it's related to the reservoirs and dams, another database. It focuses on the dams being built or that have the purpose of providing fresh water. But if you look at, I'm moving to this next slide is the hydropower dams. You can see where they are. Okay, so those places you see that have the hydropower potentials have been heavily, infrastructured with the hydropower dams. The reason that I want to use this, the example in the Southeast Asia is this reason. The Himalayas, the third pole, has been affected more significantly by climate change because the glaciers on top of the mountains are retreating rapidly. And that area, the glaciers, provide major resources, the water resources to Central Asia. You heard about the Amadaya, Sayadaya, etc. Then South Asia, Ganges and others. In Southeast Asia, the Mekongs, and in the East, that Yangtze River and Yellow River, etc. So the Earth is heavily being dammed to provide the energy, which is something you probably consider, hey, it's a good thing because it is green energy. And this is the future, okay, future, where that going to be. So future, they are going to build more and more dams. So we are really changing the world in an attempt to mitigate water resource scarcity and drought, floods, etc. So let me zoom in and then focus on the issues. Why this is a good and why this is not good thing. So thinking, looking at the Southeast Asia and then the Mekong River, which is also somehow in my, my virtual background of Zoom. It's the Mekong River basin here. The fresh water comes down from the Himalayan mountains and then trickle down through the Mekong River to Vietnam, and that provide the fresh water for about 60 million people in this area in the Mekong River Delta, in the Mekong River Basin. And then also the about 80 minority different ethnic groups. So just, to give you some ideas of what we do, is a NASA-funded project. So a major question here is, it's a nature-based solution or ecological and societal disaster in of the Mekong River dams. So we look at trade-offs, how one affects others, and look at the synergies and how we can do things together. That goes back to the WaterEnergyFood Nexus concept. Some of the issues people are facing, not only just the green energy, but also the ecosystem impacts. So you see a lot of kind of protests there, unrests, and this is just one of the dams. The people are not really for the dams, and it's affecting the ecosystem. And you can see large water bodies being, accumulated here, change the landscape, change the water resources, change the hydrology, and of course, displacement of local indigenous minorities in this large area. So there are controversial things happening. So there are trade-offs, okay? So the project has the goal to improve the understanding how large-scale human activities like, the dams to affect the WaterEnergyFood Nexus. Just have that, approach to understand the issues. So I don't want to bore you with this. Basically, what we want to do is to look at the pressures, what we call maybe stresses of climate change, land use, land cover change, and then dam constructions as drivers. We look at the processes, hydrological, and then look at the ecological process as well, and look at the impact. More importantly, we disseminate information and then assess the societal response. So this is a large project that loops back to ways how we deal or how we design sustainable pathways to mitigate climate change, or to change the land use, land cover in a way that benefits all, and then limit or construct the hydropower dams in a way that mitigate or reduce or minimize or eliminate ecological, hydrological impacts. So those are the things that we do in the project. Just to give you some of the results that we achieved. If you look at the bars that I have here, the blue bars are the water, on the left is the water storage, and blue bars is 2017 to 2030, and then 2004, the green bars are 2004 and 2017, etc. You can see that along different elevations, okay, low elevation and high elevation, you can see that, water being increasingly stored in the upper elevation. That changes the distribution and changes the access and changes the sustainability and change risk. If dams are broken or if it's drought, someone control the dam, don't discharge water, what happens to the downstream, etc. So this is a consequences of hydropower energy, moving towards green energy, resulting in water redistribution. Another thing is this Tony Sap Lake. They call it's equivalent to our, the bread basket, in the Midwest here. But in Cambodia, they provide also, about 60% of the food to the Cambodian. But you can see that it's changing. 88 and then 2016 changes quite a lot. And this is a very, very large lake. Let me show you how it changes. So if you look at the lake water level, and that's just to say this is the lake water level, and it goes up and down because of seasonal change. And then as you go, from 2001 and 2015, you see that the inundation period changed. That changed the dynamics of the lake, and a lot of fish and the species are gone because of the changes in inundation. Okay, so those are the examples. So what are the societal implications? So we are addressing. So people use water for different purpose. Of course, I talked about the dams here, okay, hydropower dams. But there are other purposes, ecosystem service, for the streams that local communities rely on the daily basis. And then the wetlands, they produce a lot of fish and other things. They are all being impacted. And the irrigation, benefited irrigation system grow a lot of food, but really change the dynamics of local indigenous people, the livelihood, the lifestyle, livelihood being changed. They are not that flexible in adapting to the changes resulting from the dams. So the traditional culture is being lost, and they have a hard time to deal with these changes from the hydropower. But at the same time, they're also facing the changes in climate as well, getting drought and floods other places. So the question is, how can we balance the trade-offs, or minimize the trade-offs, and then develop synergies? So go back to the question I posed earlier. How can we manage resources to deliver water and food and energy for all in a sustainable way? So that is a question that we still need to answer, but we don't have solutions. We don't have solutions yet. With that, I conclude this. I have some kind of summary statement on the, in the next slide, but I want to reserve that for questions so that I can, some answers, have some meaningful discussion with you all. Thank you for your attention, and we'll be happy to answer some questions.
Well, thank you so much, Professor Chee. Great presentation, so much information. I even don't know where to start because I have so many questions. But let's first start by questions from the audience. And I just wanted to remind you all that if you have any questions, please type them in Q&A. You cannot unmute yourself if you are in the audience. Please don't type them in the chat because we want to make sure that everybody else can see them as well. So we have a question from Kobe. Can we desalinate seawater by boiling it at a massive scale, therefore supplying the water on demand?
Yes, that is a possibility, but the trade-off is big. So when you're boiling water, okay, you use energy, and that you use more energy than you get from the water. So in Singapore, for example, they have large groups to do this type of research, and they want to use to desalinize seawater to make fresh water. Yes, technically it is possible, but it's financially, economically, it's impossible or impractical, at the moment. So that's where I think NSF, the calls for innovation in water energy food nexus. I think technology improvement innovations might provide some solutions, but won't be all. So people are doing this type of research.
Thank you, Professor Chee. Professor Chee, I also wanted to ask you, so you work with space technologies, you work with data from NASA and from other space agencies, and you work with a variety of computer models. So how this type of information can be translated to the public and increase public awareness of climate change in such a way that it could be also accessible? How we can bring this information to community, to schools, to the audience that is not working with those very complicated computer models?
Indeed, we work on the sophisticated algorithms to derive or extract information from satellite observations. And we put out the information through publications, a web page, etc. But that really hasn't proved to be that useful, because it's the information needs more explanation, and then the information has this kind of uncertainties that people probably don't necessarily understand, etc. And when you involve for sophisticated process-based models like biogeochemical models, one example is that we use those models to produce the CO2, the carbon dioxide emissions due to land, as a function of land use and land cover change, but those just give you numbers. How that links to the society, how that links to the activities we undertake each day, is it needs more explanation. I think that needs to be built in the curriculum so that we can teach in classroom how they are related and what we can do. So one particular area that I was involved is this CAN, so the Knowledge Action Network set up by Future Earth. So if you look at the research side, which is most of what I do, but it's going to take a while and take a significant effort to disseminate and make the information useful at the society and by the society. But the CAN was designed to work between the society and the research community. So that is the infrastructure set by Future Earth. However, I'm the chair of the Nexus CAN. We have not that reached to even a level of what we call success. Even we can't talk about success yet. So we haven't done much in that regard. So I think your network, particularly teachers, education, students, etc., would be a perfect a community that links to the Future Earth Nexus CAN, so that you can provide a linkage between the science and then the society. I think that might be something we can talk about earlier. But for the time being, it is a major challenge to disseminate the information to the society where they can meaningfully use the information to address those questions.
Thank you, Professor Chee. We have a couple of more questions from the audience. So we have a question from John Forslin. Tibetan glacial meltdown is likely to decline in the future as the ice mass diminishes. Yeah. Will populations have to move, or can the water shortage be replaced from other sources?
That's a good question, and that's so true that the glacier is retreating, and then the major 11 major rivers from the glacier, is going to sooner or later disappear. At least the water resources from the glacier will disappear. But that doesn't mean that all the rivers water from in all the river watersheds are from the glacier. So for example, I take the example of Mekong River Basin. Okay, so the glacier provide about 20% of the water. at the peak. The other water is from tributaries within the watershed. So you will see, to answer the question, you will see some people having to move, particularly in those areas where they rely on glacier water, but not all. So you will see lower elevation within the basin may or have to change, but they still have some water. So one solution, as you know, that we through the satellite, great satellite, Central Asia has a lot of groundwater, largest volume. So one way to deal with this, situation would have to be, ways to extract groundwater somehow. So that is a vision, but definitely people will have to move, and that will cause massive, migration. And you see that migration happens in other places already, Middle East, etc. So you will see migration happening in those areas when the glacial water, discharge it's been reduced to a tipping point. I don't know where that tipping point might be, but you will see the tipping point, maybe not in our life, but definitely in the next generation or so.
Well, thank you very much, Dr. Chee. And then we have the next question is coming from Christine Webster. In your opinion, is there some promising research or technology in any or all food, energy, water that might be leading a way towards sustainability?
There is a good sign. So I use the hydropower as an example. Okay, there are technologies available these days that produce hydropower without changing the hydrology. A group of researchers are doing that. MSU is part of it. So you develop new turbines that don't rely on rapid water flow, like those in Laos and other places. So that is a place where you have hydro power plants. But if you design a technology where you have this turbines that generate electricity while minimally affect the hydrology, so that is a possibility. Of course, we have solar energy. We have the technology, but we have not large, massively deploy solar panels. For example, people are thinking of putting solar panels on lakes, on the large water bodies, maybe on oceans, etc. So that could be a way to mitigate. But still, I think with the demand increasing due to population increase, consumption increases, all kinds of things, I think the advances in technologies and sustainable energy, food, water is outpaced by the demand. So but the demand is driven by increases in quantity and then changes in quality and then changes in distribution. I think I have a book chapter in that Our Future on Earth. We currently produce on a global scale, we currently produce enough food for everybody. But the fact is that we still have about 700 million people suffering from food security issue, hunger. So it's really a combination of the technology advancement and the distribution system, to get the food to where the need is. So that is one of the big issues. So in other words, there are some technologies that we are available, but have not been deployed. And there are some research, ongoing research, that seem to see some, kind of light in the tunnel and at the end of the tunnel. So that is something that I'm hopeful that it's just a matter of time. When can we get to that point? And then I want to emphasize that production is one thing, consumption, distribution is another. So we need to work on both ends.
Thank you very much. Thank you, Dr. Chee. We have the next question from Kurt Risley. You have proposed increased in demand for energy, food, and water. As population increases, I am wondering if you feel that these needs can be met without a decrease in per capita consumption.
So without per capita consumption, with the current, as I said, if I look at the food production, currently we produce enough food to mitigate the hunger, but the challenge is distribution. I think that, and I'm not advocating that we should distribute food without any cost, or it's not like everybody should get food without any effort. But the challenge is the distribution. So currently, as I said, produce enough food and water. So we have some water available, and it's the distribution that make a lot of people suffer. If you look at just the total amount of water in the Great Lakes that we are residing here, and that total amount for consumption, if you mathematically distribute around the globe, could provide significant, I think, sufficient water to people. But then what do you do, without a distribution system? That supply chain that needs to work. I think with the technology advances and the innovations in other, and I think the chart I showed the yield. If you look at the history of the food the crop yield, it's been increasing significantly over the century. But the consumption increases faster. So if we keep the same level of consumption, I feel confident to say that we have enough to support everybody on the earth based on the food production estimate we made. The challenge is that population keeps going up, and then consumption pattern. Just to give you one example, I will stop. It takes at least 9 kilos of grain to grow 1 kilo beef. We're increasingly consuming beef and not grain. So consumption pattern, there is a CAN, so Knowledge Action Network, called Food Consumption. So that group is exclusively looking at the consumption, how that can be reduced. And of course, that is also a daunting challenge.
Thank you. So I'm going to ask you another question. Who is responsible for making those decisions? Who should make decisions about water, energy, food nexus paradigm in different locations? And you work all over the world. What is the role of the local communities in this conversation?
Local communities are the ones who consume and who produce, but they are both the victims and then the causes, the causes of these problems. But to me, at the national level, decisions are made at the national level, or sometimes at the international level. But they are have very little relevance to what the decisions are. People at the local community are making. So, to me, if people at in the local communities act, that will be much better than policies and then even some of the political figures to advocate on what. So I think a lot of power is residing in the people at the local community. And we say that, in the past, still we say that think globally, act locally. That's key. Think about how much waste we have. Food, water. Just think about water. You take a shower. How long is you taking a shower, and where that water comes from, and where the water goes, and how the water is being treated. Is the water, wastewater treatment, etc. So just think of every step of your life, and if we take action to be conservative and then to be mindful of what's happening globally, I think we can make a difference. But the challenge is who can advocate and how do we get the message to the massive, everybody. I'm not saying just the people in the developed countries, but people even in the developing countries. And they get water and drink water and then they throw the water away. So that kind of actions we need to have, or at least conversations we need to have, is to promote the local community actions. So actions at the local communities are very important.
Thank you very much. Thank you, Dr. Chee. And we will now move straight to our concluding remarks by our honorary chair, George Heartwell. And I just want to come back for a moment after that to say again, huge thank you to Dr. Chee.
You're welcome. Pleasure.
Thank you, Dr. Lubimstva. And ladies and gentlemen, if you can hang with me for just 5 more minutes, maybe 6. My job is to give a high-level flyover view of this important day and the learnings that came out of it. But before I do that, Professor Chee, thank you very much. This whole water, energy, food nexus is a new paradigm for me, a new way of thinking about Earth's systems and our impact on the systems. And I very much appreciated your remarks. Also, at the very moment that you were talking about solar energy, my grandson, who is a student at Northern Michigan University, sent me an article on a 10,000 square kilometer solar display in the outback of Australia. And so the innovation and the scale of innovation is just phenomenal, I think. Anyway, ladies and gentlemen, this has been a very, very rich day. Outstanding speakers and panelists, great audience questions and insights. I don't know about you, but I feel a whole lot smarter than I did at 9 o'clock this morning. Professor Jessica Thompson of Northern Michigan University said that we're working with a 300-year-old instructional model, and we're trying to break it down and rebuild it. And I think what I heard today was that we are on the cusp of shattering that model and replacing it with something powerful and new. Climate change not only forces a new way of living, but also is forcing us into a whole new way of teaching. So some of my takeaways from today were these. First of all, we certainly live, as one of our panelists said, in a volatile, uncertain, complex, ambiguous world. And because of that, instruction must be multidisciplinary and it must be integrative. We can't solve the wicked problems of today and of tomorrow with unidimensional kinds of solutions. And instruction must be collaborative, not just within the school or the academy, but with external partners, with business, with science, with government. And we have to be systems thinkers, and we certainly can't do that in isolation. There's an important role, too, I heard throughout the course of the day today for the public intellectual, and that is you, ladies and gentlemen, on this call. The public intellectual who sees her or his role as bringing knowledge to the public square. This is especially important in a day when truth has become whatever we want it to be, or whatever is needed to serve our personal ends. And so there needs to be a factual debate in the public square, using civil discourse, something else that is in short demand, in short supply, I should say, in the world of America today. I heard a lot about thematic learning, project-based learning, teacher and students becoming literal partners in learning. I heard a lot. I was impressed with the whole notion of the shift from climate science, which is purely natural and science-based, climate change, to climate justice, which brings a human and a social and an ethical dimension to the conversation. I love the expression about saving the world one wetland at a time, because that's how we can think, that's how we can act. We act locally and it has global impact. I heard about the importance of liberal education in developing engaged citizens. I appreciated the teacher who said teachers have skin in the game, and they need to lead. You need to lead. We need to lead by example. So here's what I want to leave you with today. The challenges before you as teachers are enormous. I get that. Climate change, COVID, civil unrest, rapid changes in technology and learning, knowledge. Yours is a tough job. But I can say this with certainty. No generation of educators is better equipped to deal with these challenges than are you. Yes, teachers have always had a passion for knowledge, and they've always loved their students, and they've always sought out the next best tool for teaching. But here is what is unique about you, and it's why your students will be best equipped to solve the wicked problems. You understand that you are teaching in a larger context, a global context, and you have access to people and organizations, to resources that will enrich your instructional efforts. I hope that today you have been challenged to form new interdisciplinary partnerships, to seek out community collaborations, and to lead by example. I opened this conference by saying that teaching is holy work, and I'm going to close in the same place. What you are doing is holy work, shaping young lives, inspiring innovation, and nurturing hope. That is holy work. Thank you. And thank you all for joining us today for this important conference. And Elena, I turn it back to you with great appreciation for your effort in pulling this all together.
Thank you, George. Thank you, Mayor Heartwell. Thank you, Professor Chee. I want again to say huge thank you to all our speakers who made this Climate Change Education Solutions Summit success. And special thanks to you all for being such a great audience and for sending great questions. So thanks again.